Unit 6 and 8 review. So the reason that we're doing this is because the CBA exam is next week on Tuesday, and there's a lot of information we've learned this 6 weeks that you probably don't remember, so I want to refresh your memory before you have to take that test. There's also a couple of other things I need to add in here. So just to review you, whenever we're multiplying two things with the same base and they have exponents, what you do is add their exponents. So 2 plus 3 is going to give me 5. Now the reason is, an exponent just represents how many times that you're multiplying that letter together, so that means I've got x times x, and this one means that I've got x times x times x, and if I'm multiplying those two and those three together, that really means I've got 5x's all multiplied together, and that's why it's x to the 5th power. So in example 1, if the area of a rectangle is 20x to the 5th, y to the 8th, then which of the following could represent the length and width of the rectangle? Well, what you have to remember is that area of a rectangle is represented by base times height, which is the same thing as length times width. So basically, you're just multiplying these two things together. So if I do 5 and 4 together, those do give me 20. But if I do x to the 5th times x, well, that one really has an imaginary 1 exponent, so this is x to the 6th power. That one only has 5, so it cannot be answer choice A. Look at the next one. 10 times 2 does give me 20. X squared times x right here gives me x to the 3rd power, because I've only got 3 multiplied together. That doesn't match because we need 5. Part C. 2 times 10 gives me 20. X to the 4th times x, well, that one gives me 4 plus 1, which means now I've got 5. And y cubed, y to the 5th, I add 3 and 5. That one gives me y to the 8th power. So that means C is my answer. Now, number 2 is a similar problem, but on this one, they're saying if the area of a square is 4a to the 16th, b to the 10th, then what is the length of a side of a square? Well, remember, a square is still the same formula, base times height or length times width, but it is the exact same side for each one. So what I need to do is multiply these answer choices by themselves. So if I had 4a to the 6th, b to the 5th, well, right away I've got 4 times 4, that's 16, not 4, so it's not A, which means it also can't be answer choice D. So I'm looking between these two. Now if I multiply this one by itself, 2a to the 16th and b to the 10th, well, 16 plus 16 is already way more than that one, so it can't be that one. So it does need to be answer choice C. But here's the real reason. If I multiply it, a to the 8th, b to the 5th, 2 times the 2 gives me the 4. A to the 8th, a to the 8th, I add those two exponents and I get 16. B to the 5th, b to the 5th, those add and give me 10. Let's move down to example number 5. Which of the following is a solution set for this equation? Now there's a lot of different ways that you can do this problem, but what you need to remember is that a solution set is not an ordered pair, first of all. This is just a list of the possible answers. So what it means to actually be a solution is that it makes your equation true. So let's try plugging in our numbers in place of the x's and seeing if we get 9. So I'm going to use my calculator right here. I've got the problem x times x minus 8. So I'm going to put my first x value is -1, and I still have to use that same -1 for the second x. -1 minus 8, so I plugged it in. My x's are -1 now. And whenever I hit the enter button, if it gives me 9, that is one of my solutions. So -1 is a solution. That one's okay. Now let's check -9. I'm going to do the same thing. -9 times -9 minus 8. And remember, you use a negative sign when it's the beginning of your problem or the beginning of a set of parentheses. But if it's in between two terms, that's when you use a minus sign. When I hit enter this time, I get 153. That one definitely does not equal 9, so that one is not the answer. So it can't be answer choice A. All right. So I'm going to look at B. That one has a positive 1, so let's do the same thing. I'm going to do 1 times 1 minus 8. Hit the parentheses. Enter. That one gives me -7. So 1 is definitely not a solution, which means B is not my answer, and it also means D is not my answer. Now, I already know -1 works, but let's check +9 really fast. So 9 times 9 minus 8 equals 9. And that's exactly what we wanted it to equal, so that is our answer for C. Number 7. What is the vertex of y is equal to x squared minus 4? Now, since they did not give us the picture this time, what I want you to do is go into your calculator and type in the equation that they gave you, x squared minus 4. If I hit the graph button, I can see my vertex is somewhere right here, but let's use the table to help us find it. So I'm going to hit second graph, and I'm going to look for the center of my repeating numbers. So I see -3 and -3 are repeating, so what's in between them, 0, -4, has to be my vertex. So 0, -4 is answer choice B. Okay, let's move down to number 10. If I gave you two equations, equation 1 is the parent function, which is x squared, and the second equation is going to be multiplying something to that parent function. So they ask, if that letter A is 9, how the two graphs differ from each other. So what they're saying is if I take 9 and multiply it by the parent function, that would give me f of x is equal to 9x squared. So whenever you multiply something to your parent function, that one's either going to make it wider or narrower. So it's not going to shift up or it's not going to shift to the right. So between these two, if you've got a bigger number, that's actually going to make your quadratic narrower. But just to prove it to you, you can always plug in both equations together. So I'm going to do the parent function and the one that changed, 9x squared. If I hit graph, there's the parent function, and there's 9x squared. The parabola got narrower. Move over to number 11. This is the same type of question. I've got the parent function again, and they're saying a times that parent function, which is right above us. Now this time they gave us a as 1/7, so what they're telling me is that f of x is now equal to 1/7 x squared. So whenever you multiply it, just like on that last problem, it's either going to make it wider or narrower, and anytime that you've got a fraction like that, it's actually going to make it wider. But here's my proof. So I'm going to go into my calculator, y equals button, let's change this one to the 1/7 x squared, and hit graph. There's the parent function, and there is 1/7 x squared. And you can tell that it definitely got a lot wider. Now when you get down to number 14, if you start off with the parent function and then you make a change to it, remember that if your change is happening inside the parentheses, you're inside your house, you're ignoring your parents, so you're doing the opposite of what they said, and you are being horizontal on the couch. So that one's either going to be a right or a left shift. Now, if you are outside of the house, you are obeying your parents, so that's the one that's going to do exactly what you think it would, and it's either going to go up or it's going to go down. It's a vertical translation because you are standing up outside. Now, for number 16, you have to be careful because this problem is not starting off with the parent function. This one is starting off with x squared plus 3, and then they want to change the 3 to a -2. So what you're actually comparing is this equation and another equation with x squared minus 2 instead. If you are not sure what those changes do, plug both of those into your calculator and hit the graph button. Okay. Now number 17. It's been a long time since we've done these, but whenever you're trying to simplify a division bar with these kind of trinomials, you need to factor both of the sides. And the way that you know you're going to have to factor something is if you actually see the x squared. So I know I'm going to have to factor the top of that parentheses, and I'm going to have to factor the bottom. Okay. Now on the top, I am just dealing with the x squared plus 4x plus 3. I don't care anything about the bottom. If I'm trying to factor that thing, each one of my parentheses starts with x. I'm going to list the factors of 3, which could just be 1 times 3, but those two do add to give me 4, so that's the pair I want, plus 1 and plus 3. Now for that bottom row, I am just factoring the bottom row. I don't care anything about the top anymore. I know I've got x and x. I'm listing the factors of 2, which could just be 1 times 2. Those two do add to give me 3, so that's the pair I want, plus 1 and plus 2. Now, what you can do now is cancel out anything that they have in common on top and bottom. So x plus 1 goes away, x plus 1 goes away, and my answer, and make sure that you keep it on the same side that it's already on, would be x plus 3 on the top and x plus 2 on the bottom. Number 19. This is the last one that I'm going to do with you. All right, now in this problem, I see that I have x squared on the top part of my fraction bar, so I know I'm going to have to factor that top part. But on the bottom, I've only got a regular x, not an x squared, so that one's going to stay exactly like it is, but I'm going to go ahead and put it in parentheses just so that I can see things easier. I've got my x in the front. I'm going to list the factors of a positive 10, which could be 1 times 10 or 2 times 5. Those two add to give me 7, but I need a negative 7. Well, don't forget that when you have a positive constant like that, positive 10, double negatives also multiply to give you a positive 10. So this is minus 2 and minus 5. Now, when I cancel out what they have in common this time, x minus 5 and x minus 5, my answer is just whatever's on the top. It's x minus 2.